This video is based on the calculation of percentage. Let's go. This particular video is very important because on the part one of my video, I did not give you guys the formula for percentage until one of my students brought the questions for me, so I said let me bring it out. Now, the percentage of the original nuclei of a sample of a radioactive substance left after 5 half-life is, now it's so easy. The formula for calculating the percentage of a radioactive substance is the percentage left. Let me go with this. Percentage left is Fr all over N1 times 100. And so this is also easy. You already know what is Fr. You already know what is your N1. Now listen. Under calculation based on percentage, if you are not giving your original nuclear sample, like you are not giving N1 in the question, your N1 is always 1. Note it very well, please. If you are not giving your N1 from the question, your N1 is always 1. So already you know that Fr is the fraction remaining, which is 1 all over R. And you already know that your R is 2 raised to the power of N. And you already know that your N is T all over capital T. Then from the question, we're not even giving small t or capital T, we're giving N after 5 half-life. So I don't even need to write this. Because from the question, my N is equal to 5. So from here, it means that your Fr, let me calculate, that means here from that my R is 2 raised to the power of 5. And 2 raised to the power of 5 should give you 32. Right? So the percentage is Fr all over N1 times 100. So my Fr, which is 1 all over R, is 1 all over 32 all over 1, because we are not giving the original amount. Like I said, take it to be 1 whenever you are not giving from the question. And so times 100. And this should give you 3.125. Please, under percentage, be very careful. You are calculating to get the percentage, and so your answer is going to always be in percent. So this is 3.125, or you can say this is 3%. So this is another very powerful formula for calculating the percentage. So please be very, very careful on how to calculate this. And I want to point out a very important formula too. Remember, we said your R is equal to N1 all over N2. And then that your R is equal to 2 raised to the power of N, right? And then we point out something, because if you don't know how to manipulate most of these formulas, this is not this question I'm solving. I want to point out very important something. And then your R is equal to 2 raised to the power of N. And then your N is T all over capital T, right? So most times you want to put it direct. Let's say you want to put it direct. And let me say I ask you to calculate your N2. So from here, from this equation, your N2 is equals to N1 all over R. So you can decide to put it like this. It's equals to N1 into 2 into T all over this. You can put it like this, still the same formula. You can put it like this because your N is already small letter T all over capital letter T. I just want to make sure I teach you all these formulas, because once you are not conversant with how to use it, you may find it very difficult to use the formula. So it's just not part of this question. I just wanted to bring it under this video. Example number 6. This is I extracted this question from JAMP. A lot of people giving me the question to solve. So the count rate of a radioactive material is 800 counts per minute. If the half-life of the material is 4 days, what will the count rate be in 16 days? And so the count rate of a radioactive material, which is your N1, is 800 counts per minute. If the half-life of the radioactive, so your capital T is 4, what will be the count rate? They want you to calculate the N2, right? And you're already giving your T to be 16 days, right? And so, of course, R is equals to N1 all over N2. And so, from here, N2 is equals to N1 all over R. So, and your N2 is equals to N1 all over 2 raised to the power of T all over capital T, right? So, from here, your N2 is, what's your M1? 800 all over 2, and your capital T is 16 all over 4, right? So your N2 should be 800. 16 divided by 4 should give you 4. That should give you 4. So 2 raised to the power of 4. So here, this is 800 all over 16. 800 divided by 16 should give you 50. And your SI unit should be count per minute. Now, I wanted to give you an example that you can use that for this kind of formula and get it. If you want, you may not use this formula. You can simply go ahead. Another second method of solving this example, you can go ahead like this and say R is equals to N1 all over N2, right? And so your N2 is N1 all over your R, right? Good. So from here, you already know your N1 to be 800 all over your R. Remember that our R is 2 raised to the power of N. So if you can get your N is, let me solve it. Your N is T all over capital T. And so this will give you 16 all over 4. And that will give you 16 divided by 4 should give you 4. So your N2 is N1. Your N2 is N1 all over your R, right? As your R. Now, this is, remember your N is 2 raised to the power of N, which is equal to 2 raised to the power of 4, which will give you 16. So this will give you 800 divided by 16, which will also give you 50. So any of this formula you use, you can get the answer immediately. That is all for this video. Thank you very much.